Welcome and a very good afternoon, everyone. My name is Puneet Sharma, and I work as a senior technical instructor with AWS Training and Certification India team. It really feels so good to be here at reInvent this time of the year to talk about MLOps engineering on AWS with all you machine learning enthusiasts. Machine learning is a fascinating technology which has been changing our lives in such an innovative ways that we could have ever imagined. Right? Let's put it this way. How long do you think humanity has known machine learning? 10 years, 20 years? Any guesses? Anyone? That's a close guess. You are absolutely right. That's approximately 75 to 80 years we have known machine learning. And we have come a really long way for machine learning. All our lives are impacted via machine learning on a daily basis. The moment you open, for an example, you open Amazon application, you purchase a product, you put it in your cart, you get recommendations that people who purchase this purchase that as well. Now, how do you think that is happening? There's a recommendation engine, there's a model, we call it as a machine learning model, which is running under the hoods to provide you with those recommendations. You make a financial transaction, sometimes you get a notification that is it really you who is making that transaction, and then you intervene in between yes or no. That's a fraudulent detection machine learning model which is under the hoods. We'll talk about machine learning operations today. Machine learning and the innovation which are done with machine learning using multiple steps. Having talked about machine learning, we have come a really long way, and one of the fields of study which has gained prominence over past few years is machine learning operations. Now, whenever I am into customer discussions, people do ask me this question, Puneet, what's that one liner which you would say about machine learning operations? What is machine learning operations? MLOps is all about creating a ML model and keeping it productionalized for a long period of time. That's a one-liner. That's at the heart of what we do with machine learning operation. Now, having said that, there's a lot which goes on into creating an ML model. We would like to build a machine learning model. You would train a ML model. The training of an ML model is when you pass the data to an algorithm, and the algorithm learns patterns within that data. Now, approximately, if I remember right, around 10 years back or so when I started my journey on machine learning, people used to ask this question, Puneet, isn't it machine learning a fancy way of saying pattern recognition? And they were not wrong from their perspective. Machine learning is all about pattern recognition. And that's what the algorithm does for you in the training phase. Then we deploy the ML models in production. You would constantly monitor the model as well. We would like to retrain the models also periodically over a period of time. And we would like to automate all these steps in a pipeline. That's what MLOps is all about. So operational perspective of machine learning is to keep that models into production and keep it that way for a long period of time. And that's what we are going to discuss today. Consideration and challenges. Now, with every technology comes with certain challenges as well. You would have cultural difficulties. We'll have lack of cross-functional teams when it comes to MLOps considerations and deploying those ML models into productionalized environment. You would have priorities and needs of people would be pretty much different at point of times. I need to sometimes reorganize the structure of the organization as well in order to have a successful machine learning operations workload being created. You would require the right skill set of people. You'll require an ETL engineer, you'll require a data scientist, you'll require a governance officer, and a bunch of other skill sets would be needed in order to create a successful ML model. And then every machine learning model has its unique ML lifecycle as well. Every model is different in its own aspect. That's what makes it unique. Now, a lot of times, we have a misconception that machine learning operations is all about technology. And I would like to emphasize upon that fact here that MLOps is not only about technology, indeed, technology is one of the pillars, it's one of the strongest pillars of MLOps, but you also have people and processes are two most important pillars along with technology. MLOps is how you approach to machine learning. We would like to minimize the human intervention as much as possible in an automated pipeline. And that's our entire agenda of creating these MLOps workloads. Now, there's a lot of things which goes into a machine learning model. It's not the model itself. Of course, the model is that place where the magic is happening. The model is that artifact which is making the predictions for you. You send a payload to a model to get a prediction from that model. For an example, I'll send that, okay, that's the past 1 month data for an X stock. Please give me the prediction for the next week or probably for the next month, whatever that prediction I like to make. So model is that artifact which is used to make predictions. But that's one aspect of MLOps. There's a lot much thing which goes into the machine learning operations. You also require the infrastructure where the model is hosted. I also need monitoring on the machine learning model as well. I need a mechanism which can capture utilization, which can capture CPU utilization, which can capture the number of HTTP requests which have come into my infrastructure. I would require to capture bias. I would require to capture the data drift. I would need to capture the model quality drift as well. So there's a lot of things which goes on into operationalizing and keeping those models in that state. And that's the real hard part. That's where all the real job of an MLOps engineer comes into the play for us. So our agenda for today is we'll talk about those 3 pillars, which are the foundational backbone for MLOps. That's your people, processes, and technology. We'll also talk about security and governance today, and we'll talk about the maturity level of machine learning, the MLOps maturity model as well. And I'm a very firm believer that technology could not be learned just by listening to theory. So I do have a demonstration as well. Towards the end of the session, I'll take 5 minutes of yours to show you an actual working pipeline of an ML model. So you get to solidify your learning, whatever we'll be discussing over this period of next 1 hour. Let's start off with processes, first of all. Now, what you see on my screen right now is an actual flow of how an ML model gets created. We first of all start with a business problem. You identify what needs to be solved, and then we convert that business problem into a machine learning problem. I always say this to my customers whenever I am into a discussion with them. If you have the capability of doing something, it does not mean that we have to use that. Machine learning is not a magic wand. It's not a solution to every kind of a problem. If you have the capabilities, you have the liberty of using machine learning at your disposal, it doesn't mean it's necessary for us to use that. It involves cost, it involves skill as well, and it involves a good amount of time investment also. So there's always a trade-off between the amount of work which you want to do and the kind of the workload which you are creating. Say for an example, I'm working for a bank and I want to create a machine learning model which predicts that on the basis of a credit score, you need to disburse a loan to an individual or not. Now the only criteria on the basis of which you are going to do this classification is your credit rating, which is above an X percentage, above an X threshold, let's say it to be 700 or 750. Now, do you think machine learning is appropriate for this kind of a use case? Can I have some hands? Do you think yes? Can I have some hands for this? Right, how many of you say no? Not required, we don't need machine learning. That's absolutely right. It's only a single criteria on the basis of which you are going to do this decision. I can write 5 lines of a Python code for this, or I can probably use some other tools as well to just sort of filter the data. But contrary to this, if the plausible conditions on the basis of which you are going to do this classification is not only the credit score, it also includes the income of the individual, it also includes the existing credit which the customer is having. It also includes educational qualification, marital status. It includes the number of dependents and a bunch of other factors and features on the basis of which you are going to make this decision. Now, do you think this is an appropriate use case for machine learning to identify whether I should disburse a loan to an individual or not? Can we have some hands? Yes? That's a plausible use case. Right. So that's where you convert that business problem into a machine learning problem. Machine learning problems are always quantitative in nature. They are never ever qualitative. You cannot say that while deploying an ML model, I want to increase the profitability for an organization or I want to decrease the losses. You have to be quantitative here. Once your ML models have been deployed into production, after 2 months, after 3 months, I need to see 10, 15, 20% increase in the revenue, or whatever is your metrics in that case. So that's always quantitative. The next step in your machine learning operations, in an ML pipeline rather, is to start with your data collection. And that's one of the most important phases. 60% of ML engineers and 60% of data scientists, they say that we spend most of our time on this aspect. We spend most of our time on collecting and cleaning the data. You'll be surprised to know 15% of the effort goes into model training and hyperparameter tuning. It's maximum amount of time the engineers are spending, the ML engineers, data scientists are spending, are on data collection and data preparation activities. Typically in the field of machine learning, we say the larger the good quality data, the better it is for the machine learning model. That's how close your model is going to make the predictions for you. We never say that larger the data, the better it is. No, it's the good quality data which you need. The data needs to be representative of the kind of predictions which you are trying to make. And that's what is going to be the differentiating factor. Data is that differentiating factor. So you start with the data collection, we move over to the feature engineering phase. That's the place where you are increasing the predictor power of your model. I'm fabricating my data, I'm pre-processing my data so that my model gives me the appropriate results. As close by to the actual results, as close by to the actuality what is possible. Once you do that, once we have the feature engineering in place, the next step is your model training and tuning. And that's where you pass the data to the algorithm. You have algorithms, traditional algorithms. We use XGBoost and linear learner. You can use neural networks as well for this. And that's where that data is passed to the algorithms to learn the patterns. Once we have the model training in place, we evaluate the model, whether the model is appropriate, is it giving me the correct results? A lot of time I get this question as well, Puneet, what do you think is a good metrics, is a good accuracy for a machine learning model? Is it 60%, is it 70%, is it 80%? My answer to that is, it always depends. It always depends on the kind of the workload, the industry, the environment in which you are working with. Probably for an entertainment industry, if you're trying to create a machine learning model, it's okay for me to have a accuracy of the model around 60% to 70%. But when it comes to healthcare, when it comes to manufacturing, when it comes to any other kind of an industry, financial transactions for an example, I would require my model to give me accuracy of more than 90%, probably 95% to 98% in certain cases. So that's where you evaluate the model. If your model is meeting the business objectives, we would like to deploy the model into a production environment, which means we'll be creating a web server and it's ready for a productionalized use cases. You can integrate that web server endpoint into your application. But what if the model does not meet your criteria? The accuracy is less than anticipated. It's less than 90%, it's less than 80%, whatever we have said. That's where we go back and you start with data augmentation. Your data is not representative of the kind of the model you are trying to create. I need to get more data. I need to add more features. I need to do a bit more feature engineering. An example of feature engineering I can tell you is, let's say you have a column in your data which is in the form of DD, MM, and YY, date, month, and year. Right? And I'm creating a predictive routing kind of a mechanism where I need to divert the calls of the customers to the correct call center agent, to the backend agent, based on the registered mobile number which they are calling to us. Now in this scenario, it's much more better to convert that column from a DDMMYY format to an integer value, subtracting today's date from that DDMMYY, the date of purchase, that is. So that gives me an idea that, okay, the customer has purchased this product 20 days back, 30 days back, whether it's in warranty or not, where do we need to divert the call for this customer and so on. That's where feature engineering helps you out. Right? So we go back to feature engineering, but if my model is meeting all the required objectives, we'll productionalize the model, we'll deploy that model, and one of the most important aspects would be we would monitor the model as well. Machine learning models are known to lose their predictor capability over a period of time, and you need constant retraining of the model as well. Now, MLOps is not only about the code. Machine learning operations is also about data, and at the same point of time, it's also about the model as well. I get this question often, Puneet, what's that differentiation between DevOps and MLOps? DevOps is all about data. MLOps is an extension to that DevOps practices, which also talks about the model as well, and we talk about the data. That's the differentiator here. So one of the key differentiator is you make a commit, you change your algorithm. For an example, I change the hyperparameters of my algorithm. I change any other settings for my algorithm, and I commit the code back on the repository. That should trigger my machine learning pipeline. Which pipeline? The one which you see, data preparation. That's where my pre-processing is going on. Then I should automatically have a model build. I should automatically have an evaluation phase being done. We should select the model, register that model. We will deploy that model as the necessity might be. I'll deploy it as a 24/7 running server, or I'll probably use a batch inference or a kind of a serverless or an asynchronous inference as the use case might suffice. And then we are going to constantly monitor the model as well. That's the MLOps pipeline we are going to see today. So if we dive a bit deep into the world of machine learning operations, the first aspect is you are going to manage the data throughout the ML lifecycle. During the data preparation stage, there's a lot of things which goes on. There's a lot of things you need. You need to clean your data. You need to do feature engineering. You might need to divide your data in a training, in a validation, and a test data set. Now, if you're wondering, Puneet, you are talking about validation and training and test data set, which means we are only talking about supervised machine learning here. The answer to that is yes. I'm only talking about supervised machine learning right now in order to understand the concepts of it, but the same concepts would be applicable to an unsupervised machine learning as well. Can I have some hands for the participants who are already working on machine learning and they have created some supervised or unsupervised machine learning models? So I do have many participants who are already. All right, how many of you are completely new to the field of machine learning and MLOps and starting your journey? Can I have some hands? Right, so that's approximately 30% of the audience is new to machine learning as well. All right. So I'll try to keep it as simplistic as possible. So the concept of this dividing the data is more likely applicable to your supervised machine learning. So what you see here is your training, validation, and test data set. Out of this, your training and validation data set goes on to the algorithm. Test data is left over for your evaluation purposes. We generally evaluate the predictor power of the model using that test data which we have. So I need mechanisms, I need a data repository to hold all that data for me after my data has been processed. I need to manage the code as well. Now you might be wondering, Puneet, what kind of code are you talking about here? I'm talking about the pre-processing code. I'm talking about the algorithm which you are using, and I'm talking about the inference code as well. I need repositories where I can make those changes if any changes are to be made, and that should trigger the entire pipeline for me. And lastly, I also need a repository for my model as well. You could have different versions of your model created. Now, what are the most likely factors when you would create different models? I would create different models based upon different algorithms. I would create different models using different set of hyperparameters. I could create different model versions using different kind of feature engineering jobs done on my data itself. These are certain ways through which you create different versions of your model, and then I pick up the best model and productionalize it. Or you probably pick up two models and you send 50% of traffic to one version of the model, and I send 50% of the traffic to the other one. Either way, it's possible. So the ML lifecycle as a whole looks something like this, involving your data preparation stage, model build, evaluation, selection of the model, deployment as necessary, and then the aspect of monitoring. This one slide explains everything which you need to know as a differentiator between DevOps and MLOps. Like I said, DevOps is majorly about code. MLOps extend that culture of DevOps, and it includes your data, data provenance, data sets, and it includes models as well. It includes the metadata repositories which I need to hold the different versions of the models which I have created. Now let's talk about the second important pillar, which is people. In a typical organizational role, you will see ETL engineers, you will see DevOps engineers, you will see data scientists, MLOps engineer, governance officers, and you would have model approvers. We need these kind of roles during different phases of my machine learning pipeline. Data engineers are needed who are responsible for cleaning up your data. You would require data scientists. These are the people who are responsible for setting your algorithm right. A lot of times I get this question as well. What's the level of mathematics which is needed in order to start with machine learning? And then I always say, it again depends. One of the most diplomatic answers you can say, it always depends. So it always depends, likewise, and I'm not joking about it as well. It actually depends, because you can do pretty well good in the field of machine learning without ever diving deep into the world of mathematics. But if you are into a role of data scientist, then yes, I need to know about combinatorics. I need to know about permutation and combinations, that is. I need to know about set theories, matrices and determinants, integration and differentiation is all the level of mathematics which I need in order to fine-tune my algorithms. And that's the job of a data scientist. That's where they are going to create those algorithms. I'll change the code and commit that code to my repository and see my pipeline getting executed. You would require your model approvers. Typically, these are the people who decide that, okay, it's 70%, it's 80% of your accuracy, or your root mean squared error is below a particular threshold. That's okay for my use case, and now I approve the model to be deployed into production. You require a governance officer. These are the people who take care of that you are not using any PII data or any personal health information or protected health information, personally identifiable information, which can jeopardize the machine learning models. So that's why I require governance officers as well. You require DevOps and MLOps engineers in order to create that pipeline and connect all those components together. Having said that, it's a typical scenario you might see certain roles being overlapped. For an example, data scientists can also do the job of ETL engineers, which is pretty much okay as well. Right? They know how to collect the data. They know how to write a Python or a Spark code for cleaning up the data as well. Communication is very important in MLOps, and that's one field which we sometimes overlook as well. You would require collaboration among different team members, and you require communication among different teams in order to have a successful ML model. To optimize the performance through smooth handouts, that communication is very, very vital. Think about this. Where are you on your ML team? How many of you are working as data scientists? Can I have some hands? Very few of you. How many of you are ETL engineers? We have a bunch of ETL engineers as well. So think about this. Where are you in terms of your life cycle? Are you in the business phase, the data collection, the development phase of the model? Are you on the deployment or on the monitoring stage of your model? Let's come to the most fascinating part now, which we as technology enthusiasts are much more concerned about, is what technologies we can use. Implementation considerations for ML is when you select a technology, you should always select a technology which is consistent, which is flexible enough. Flexible in the sense that machine learning is a highly iterative job. So I need flexibility to accommodate those changes which my model is adapting. I need technology which can be reproduced as well. I need a technology which can scale with the number of requests coming in, right, which can decrease with your number of requests going down. I need auditability. Who made an API call? At what point of time the call was made? And look out for a technology which supports explainability as well. If your model is making a prediction, why is it making that prediction? So technology in MLOps could be divided in two categories here. You would need technology around ML infrastructure, and you would need technology around task orchestration. And there are various tools which can be used for this. The good thing is Amazon's SageMaker as a service provides me all these capabilities in a single stop shop for us. I get really fascinated when it comes to SageMaker. It's just such a fascinating service to work with. And believe me, when I say this, SageMaker is a single-stop service for all your machine learning needs. It will help you with data collection, with data pre-processing, with model training. There are a lot of inbuilt algorithms which are provided with SageMaker. It helps you with model deployment. It helps you with monitoring as well. There are a lot of features and capabilities inside SageMaker. It's a completely managed service. But then if you have your own algorithms, you have your own orchestration mechanisms, you say, I'm more of a DIY person, do-it-yourself person. I would like to manage everything on our own. You have the capabilities of using EC2 and container and Kubernetes services as well, which can be used to orchestrate your entire tasks and processes. We'll focus on SageMaker today. Let's talk about how SageMaker and what components and features of SageMaker can help us to create these effective machine learning pipelines. SageMaker provides me with the feature for data repository. Any guess anyone can make on which feature in SageMaker works as a data repository for us? Exactly. That's your SageMaker feature stores. You have code repositories, and we do have model repositories as well. SageMaker provides me with capabilities for all these. Right. With SageMaker, you can streamline your entire machine learning operations pipeline. You can automate your ML life cycles to scale your model development. You can build your effective CI/CD pipelines as well for ML to orchestrate your models. You can catalog different model versions. There's something called as a model registry inside SageMaker, which helps you to do that. You can use SageMaker features for tracking the lineage of the data as well, and I can maintain accuracy of predictions after the models are deployed. All that could be done with SageMaker. So here are some of the features I was talking about. You have SageMaker Data Wrangler, which is a GUI way of cleaning your data. That 60% of the efforts where you put in can be performed in a more effective manner by the use of SageMaker Data Wrangler. No need for writing your code for more automated tasks. Use SageMaker Data Wrangler for that. You have processing jobs. Once you get your scripts ready, I can spin up a compute environment and pass that script onto SageMaker processing jobs for cleaning up the data. You have feature store, which is your data repository. You have SageMaker training jobs. That's where we combine the algorithm with the data and the pattern recognition happens. So SageMaker spins up the effective infrastructure for you. It gives you the servers on which you can start your training jobs. You do have the capabilities of model registry as well, which acts as a metadata catalog for my model. You have SageMaker inferences. We have 4 types of inferences which SageMaker provides to you. You have a real-time inference, which is a 24/7 running server. Then you have a batch inference as well. You have a serverless inference, and we have an asynchronous inference as well. These are the 4 types of inference endpoints, depending upon your needs. So at Amazon, we always believe in working backward and what matters for the customers. And that's something which customers asked us to develop. They say that, okay, we don't have a requirement for a 24/7 running server. We have intermittent traffic patterns. Some request comes in the morning, and then some request comes in the afternoon for making the inference. Do I need to pay for the servers running 24/7 for them? Not now. You have serverless endpoints to support that. And then you have model monitor as well. These are the capabilities which will help you to monitor your model in production. Let's talk about an important pillar extending the machine learning operation workloads that's on security and governance. Security is a day zero job. And another field of study you will see gaining more prominence is machine learning security operations now. Just like you have DevSecOps, we have machine learning security operations. Security is by design. It's inbuilt into the entire pipeline. Security is never one person's responsibility, or it's never the job of a security engineer to imply security mechanisms on your endpoint. Security is by design right from the very beginning of your pipeline. Think about network security. Think about code and container security. SageMaker uses containers a lot for training your machine learning models as well as to host your machine learning models as well. We leverage containers for doing this. So think about container security. By default, SageMaker inference containers are internet enabled. You might want to control that. You might want to give only the respective networks access to your inference endpoints. Think about your model security. The model artifacts are stored on an S3 bucket by default. Right? You might want encryption mechanisms on which those models are being stored for us. Think about data security. From a compliance perspective, you might have requirements to encrypt your data. SageMaker natively integrates with KMS, Key Management Services, as well as Cloud HSM for meeting your encryption at rest, and it integrates with ACM as well, Certificate Manager, for encryption in transit. So security is, a lot of components of security are inbuilt into SageMaker for us. You have network and infrastructure isolation. You can spin up your SageMaker domains inside your own VPC, inside your own network, that is. For authentication and authorization, you do have identity and access management. And on top of that, you have Identity Center as well, which is a successor of AWS SSO now. So you can use third-party identity providers as well for authenticating and authorizing your users to use your SageMaker domains. It gives you comprehensive data protection capabilities. It gives you auditing and monitoring capabilities. So SageMaker is natively integrated with CloudTrail, and it's natively integrated with CloudWatch as well. SageMaker emits a lot of metrics around CPU utilization, around number of HTTP requests coming into your infrastructure, and these kind of metrics are emitted to CloudWatch, on the basis of which you can monitor your entire workload. And then there are a lot of compliance certificates as well. SageMaker is compliant with Service Organization Controls SOC1, SOC2, and SOC3. SageMaker is also compliant with ISO 27001. It's compliant with your Health Insurance Portability and Accountability Act. So there are a lot of third-party compliance certifications under the hoods which are already there with SageMaker. Another important pillar is your ML governance, machine learning governance. Why do we need governance at the first place? We need governance to standardize documentation and the processes. I need governance for capturing the business metrics. You need governance from a user group's perspective. There would be multiple personas. You need governance for permission management. For an example, I would give only the access to those IAM users when my condition matches some regex patterns. And so create these kind of identity-based or resource-based policies with conditions. That's where you need ML machine learning governance in place. I need governance for monitoring the behavior of an ML model, whether it is behaving as expected. Right? To detect any kind of a performance issues, I need governance for that as well. And more likely, you also need governance from a transparency perspective. You need to audit your ML models periodically. And you also need to abide by certain compliances and regulations. Many countries enforce this. If your machine learning model is making a prediction, why is it making that prediction? You need to explain that. Which features are taken into consideration for your machine learning model in order to derive that behavior, in order to come to that prediction? So I need explainability as well. The good thing is, SageMaker provides you with features around governance as well. You have 3 features which we typically use for governance in SageMaker. You have a role manager, we have model cards, and then you have a model dashboard as well. Model dashboard is kind of a one single dashboard location for you where you can take a look at different machine learning models of yours, how they are performing, which algorithms has been used to train them, what's the accuracy, what's the error rate for those models. All that information which you need about the models at one single place is your model dashboards. Right? More fine granular details you need about your models, we have model cards for that. And then you have a role manager, which is used for unified permission management, which I was referring to previously. Always abide by the principle of least privileges. So role managers can help you get started more fast with creating and deploying your workloads using SageMaker. Now, what is the cost? Just think about this. What is the cost of not implementing machine learning governance in your organization? And that could be fatal. Right? It can lead to the increased time in deployment of your models and increased time towards your model governance activities as well. The last pillar on machine learning operations is the MLOps maturity model. Let's try to take a look at what this MLOps maturity model talks about. We read this slide from bottom to top. The MLOps maturity model talks about different phases through which your organization goes through when you are increasing your workloads and you are moving towards a more matured organization which has implemented machine learning workloads for a substantial period of time. The first stage is your initial stage of MLOps. That initial stage requires a lot of experimentation. Machine learning is a very iterative job. So it requires secure mechanisms and you require multiple iterations, and that's the initial phase. After you are done with the initial phase, you say, okay, I would lock in on, I'm going to use XGBoost algorithm, and these are the hyperparameters which I'm going to use. This is the feature engineer which I have done on my data. Once you finalize on all that, we move over to the next step, which is the repeatable phase. And that's where the automation starts up. We try to minimize the manual processes as much as possible, and we try to move over to the automated processes. You create scripts. You create scripts for data pre-processing. We create scripts for model training. We create scripts for testing as well. Once you have automated everything, then comes your reliable phase. That reliable phase talks about multi-account architecture. Whatever processes you have created, we can deploy those processes across different accounts. That's all about reliability of your machine learning models. It's very unlikely that you would have a single account for deployment. You keep one account for development purposes, and I keep a separate account for production purposes. The good thing is we have code pipeline for doing this, and there is a feature in CloudFormation which can help me to deploy my infrastructure across different accounts. Any guesses, anyone, which is that feature in CloudFormation which helps me to deploy my infrastructure across different accounts? Let's say I produce a model in my development account and I want to deploy it in a production account. Which feature of CloudFormation can help me to do that? Stacks. That's stack sets. So you have CloudFormation stack sets. It's not stacks, right? It's your stack sets which helps you to do that. Right? You can deploy your infrastructure across different accounts and across different regions as well. The good thing is, in code pipeline, you have CloudFormation stack sets as one of the actions. So this process becomes a bit more easy for us. And lastly is your scalable stage. That's where we standardize the processes, you create documentation, you create sharing mechanisms across cross-functional teams as well. Right? I create a scalable architecture. So these are the 4 phases of your MLOps maturity model. Most of the organizations, talking in present terms, are in initial and repeatable phase. We do have certain organizations who have moved up to the repeatable, scalable phases as well, but there's a bunch of them which are still in the initial phases. The aspects of initial stage still remains the same. You have collaboration, data processing, training, and deployment still remains the same. But if you take a look, Initial stage is where we have more manual processes in place. When you move to the repeatable phase, that's where we try to minimize the manual processes and we try to move to the automated processes as much as possible. When it comes to the reliable phase, that's when you try to include governance in place, model governance in place, and I try to have a multi-account architecture. And then you move over to a scalable phase where I have an expanded architecture. My architecture can expand and contract as the need be. I can increase the number of instances. I can decrease the number of instances on which my model has been deployed as the need be. All right, so before we come to a key takeaway, I would like to show you a small little demonstration I have on MLOps. So what I've done is, I've used code pipeline to create a pipeline for a model training. It's called as an Abalone pipeline. And I'll quickly walk you through what I have done in this architecture here. So my pipeline gets triggered using 4 key sources. There are 4 repositories which we have. There is a model source repository. There's that ETL source. I have a data source which is on S3, and then you have a test source as well. So this model source repository is where all my training code, the model training code is located. I have used a TensorFlow-based deep neural network for this use case. Abalone are your seashells, and we use, it's a regression type of an algorithm where I'm trying to predict the age of those abalones. So that's the algorithm. ETL source is the one which I'm using for data pre-processing. I would need to clean my data. I would need to do some feature engineering. I would divide my data. 80% of my data goes into training. I've kept 19% of my data is used for validation purposes and 1% for testing purposes. Although that's not an appropriate percentage, I should go in for 80, 10, and 10, but that's for a POC purposes, for a demonstration purposes. So I've used 80, 19, and 1% of the data for my ETL purpose. And then your data source is S3, which means the moment I get some new data loaded on your S3 bucket, there's a put item API call on my S3 bucket. That should also trigger the entire pipeline for me. And lastly, you have the test source, which means you are setting your thresholds out here, what's your level of accuracy or your errors which you need in order to productionalize your model. Right? The next thing is I come to the build stage, which is powered with code build. In this step, I'm creating an ECR repository, which is all about my code, and I'm going to use that repository during the training phase. So my code build creates an ECR repository, and that ECR repository is my training code. The next step is an ETL stage where I'm triggering a glue job via a Lambda function. Now you might be wondering, Puneet, why have you used a glue job? Why not you have used SageMaker Data Wrangler? It's pretty much okay. You can replace this with Data Wrangler as well. I'm just using a glue job because when I created this a few time back, at that point of time, this was more likely for the customer to have used glue jobs. They were more acquainted with that. We move to the approval stage after that. So that's a manual approval as of now. I have used in code pipeline. So once the processing is done, fine. My glue job gives me an output on an S3 bucket. I send an approval email to the data approver. They take a look at the feature engineers. They take a look at the quality of the data, and then I get an approval back. So if that approval is okay, we move over to the next stage. And that's where I'm triggering a Lambda function which makes an API call to the SageMaker fit method, which starts my training job. SageMaker spins up an EC2 instance for me. It downloads the container image from that ECR repository, which I've created in that step above, and then it starts my training process. So that's your train phase. Now, after the training has been done, the next step would be to approve that model. So again, I have used a manual approval in place. You send a notification to the approver. They take a look at your error or your accuracy, whatever metrics you are using. In this scenario, I'm using a metrics which is root mean squared error. It's a regression model, so the most likely, the most plausible metrics which you will use for evaluation of regression models are either your root mean squared, mean absolute error, R squared, coefficient of determination, or these metrics are used. For your classification models, we use accuracy, precision, recall, and F1 score. So the approval in this case is done via taking a look at your root mean squared error. Then we deploy the model into a development environment. That's your model deploy. I spin up a code build environment which creates that CloudFormation template for me, and it deploys the SageMaker endpoint. I'm using CloudFormation to deploy that SageMaker endpoint. And then we run some system tests here. So that's an automated test I have included in the pipeline. For the automated test, what I have done is I've used AWS step functions. Step functions is an orchestration mechanism which you can use for orchestrating multiple API calls on AWS. For an example, you need to orchestrate multiple Lambda functions to be executed in parallel or probably sequentially on the basis of when logical condition you might want to trigger one Lambda after another one. So all that workflow you can create using step functions. So that's what I'm doing here. For test purposes, I'm using step functions. If my test goes through correctly, then I go ahead with the deployment into a production environment. So the deployment into your development environment and the production environment pretty much remains the same. The only difference is my development environment is on low power DC2 instances, and I have not configured the development environment to be on an auto scaling group. My production environment, which I have spinned up, is using an auto scaling group alongside with high power DC2 instances. I'm using some C5X large or a GPU-based instances I use for this deployment. So this part you can also shift over to your production account using your CloudFormation stack sets. Right. So this pipeline gets triggered in 4 ways. Let me also quickly show you my repositories. Now, in the interest of time, I have already created few of these repositories. That's my MLOps repository here, which I'm using for my code, and that's my model.py, and that's my algorithm code. That's the neural network, deep neural network using TensorFlow I'm using. So I'll just make some changes in this code. I'll try to commit it, and we'll see if the pipeline gets triggered automatically or not. Let me quickly show you SageMaker endpoints as well. So that's your SageMaker endpoints, and if you see, there are 2 endpoints out here. I have an Abalone dev endpoint. Take a look at that dev endpoint. If I go to the settings of this, I've not enabled the data capture on this endpoint. And take a look at the EC2 instance type is T2 large. So it's a small powered EC2 instance. I have not configured auto scaling on this development endpoint because it's only there for testing purposes. It's not a production environment. Contrary to this, if you take a look at my production endpoint here, my production endpoint, I've turned on the data capture as well. So I'm capturing all the payload which is being sent to this endpoint of mine. I'm using a C5.large, which is a high-powered EC2 instance, and I have turned on auto scaling as well. So I'm going to scale between 2 to 10 instances. The good thing is SageMaker automatically takes care of the scaling activities as well for us. You don't have to spin up your own auto scaling group, front-ending a load balancer along with it, and so on. SageMaker endpoints automatically scale your instances based upon different metrics. You can configure those metrics on your own. Right. So that's the difference between my dev and my prod endpoints. That's my ECR repository. You can take a look. That's the Abalone repository I have. Over a period of few years, I've made multiple changes on this repository. This is the one which I'm using now. That's the most latest image we have used. And that's the step functions. So this is what I was referring to you previously. That's your step functions. That's where I'm doing the automated evaluation of my machine learning model. If my model is below a particular threshold, model below the quality threshold, then I suggest a baseline, and then we register the production model. Once you register that production model, my SageMaker production endpoint gets created. You can use step functions for multiple other purposes as well. I'm using this for and automated testing. You can use step functions for orchestrating your training jobs as well. You can use step functions for orchestrating your ETL activities, your data pre-processing job also. So it's a workflow orchestrator. Anyone know any other tool besides step functions which can help me with this task orchestration mechanisms? Any guess, anyone? Sorry? SQS queuing service? Okay. Exactly, that's your Apache Airflow is one. You also have Kubeflow, which could be used for this. You also have MLflow is an open source, which can also be used for these purposes. And then there is a feature inside SageMaker itself, which is your SageMaker pipeline. And that's why I was saying SageMaker is that one service. If you use that, you most likely do not need to go anywhere else. You do not need to look out at any other components or any other services in order to create your MLOps workloads. SageMaker pipeline can also do the same thing for me. So right now I'm just using it for these purposes, and that's my data repository. That's the S3 bucket, and that's the CSV file, which is used for training purposes. Now let's do one thing. I'll just show you how this pipeline gets triggered. There are multiple ways. I'm just going to upload a new CSV file on this S3 bucket, and let's try to see if the pipeline gets triggered automatically for us or not. Right. And then we'll have an open house for Q&A. Let me just upload this CSV file. Right, and let's try to come to a pipeline. Let me just refresh this and see. All right, so the upload is successful here, and all right, and there you can see the pipeline gets triggered. That's just now. How this pipeline got triggered, either I upload some new data, either I would have made a code change, that should trigger your pipeline. And that's the differentiator between your DevOps and machine learning operations. And then you have the build phase, which is going on. We'll have the ETL after that, which will take place, and then the rest of the phases will go through. Right. So key takeaways from this session. MLOps is a journey. It's not an end. Think about it from a collaboration perspective. Think about experimentations. Think about your path to production. Adopt MLOps practices with SageMaker. Build your CI/CD pipeline. Automate as much as possible. Track lineages automatically. Right. You can take out your mobile phones if you want to scan these QR codes. We have documentation here for white papers and a lot of AWS ML guides. We do have classroom trainings as well on DevOps engineering on AWS, and we do have a classroom training on machine learning engineering on AWS as well, where we dive more deep into the world of SageMaker. We dive more deep into the world of code pipeline and repositories and all these things. Please visit our developer pavilion. We have a team of experts there to boost your skill and help you get to the next level. Feel free to join boot camps, spotlight labs, AWS jams, and escape rooms. We have breakout sessions as well. One very important thing, I'm sure most of you would have your skill builder account created, but just in case if you have not, please create a skill builder account. Please scan this QR code and create your skill builder account. You will find a lot of curated and pre-created courses and lab exercises which you can leverage and learn at your own pace. One very important thing, we are having 50% discount for examinations, any AWS certification which you are planning to write. This is applicable till 31st of Jan. Please scan this to claim your voucher code. Most of you would already have that. Thank you very much, everyone. It was really a pleasure for hosting this for you.